Yo guys, welcome back to another video on differentiation. So in this case, we're given a cuboid as an example now. And here we're trying to prove and find the maximum value of the volume of this cuboid. And we also know that we're given a surface area of 60, some lengths y, x and x. This of course implies that this part is a square and this part is a rectangular base. So without further ado, let's kick it off. How to find the maximum value of this cuboid in general? Well, the key idea is always, since we're working in volumes, we need to find the second derivative of the volume with respect to, let's say, x twice, and to show that this value of whatever x you use will have to be maximum, will have to be less than 0. This is where we need to be. Now how do we get there? Well, because we're given some information about the surface area, and because we know we need to find a volume, we should firstly kick things off by making two equations, one in surface area and the second in a volume. So let's do this. So first things first, let's find the surface area equation, okay, because we know it's 60. So look at the shape, how to get a surface area. Well, given that we need to know that the surface area implies that how many faces we have, we know that the rectangular side has 4 faces, one here, one there, behind and the bottom. We know the length is y and x, so x times y is xy, multiplied by 4 is 4x y. We also know there's 2 square faces with dimensions x and x. So x times x is x squared. 2 lots of it, so 2 lots of x squared. Of course, all of this equals to 60 because that's pretty much the given part of it. So this would be one equation. The second equation would be the volume now. How to find the volume? Volume is actually a hell lot easier than surface area because all you do is multiply their dimensions. So x times y is literally x squared y. Now here comes the problem. The problem is to eliminate one variable. My advice is, depending on what the question asks, if the question usually asks us to put in terms of x, we want to eliminate y. So let's just go with the assumption that we want to eliminate y and work with x. So using the first equation, because we're trying to deal with the volume, we need to put something into here. So let's rearrange this to make y the subject. So what I could do is subtract 2x squared and then divide 4x. Will give us y equals 60 minus 2x squared over 4x. Simplifying this would give us what? 15 over x minus, dividing these two, will give us x over 2. Not bad. Now all we do is pop this into here. So replacing y with our newly found 15 over x minus x over 2, and expanding this as we should actually get v equals 15x squared times these two times 15 over x should give us 15 over x, 15x squared over x, of course, which eliminates 1. So we're left with 15x. Why? Because we eliminate one term each. Minus x squared times x will give us x cubed over 2. Simple. Now, what do we do here? So here we need to find the derivative and use that value of the first derivative to plug into the second derivative. So without further ado, let's find let's find the first derivative, dv over dx. So differentiating this one, we should get 15 minus, differentiating this equation, drop the 3, we should get 3 over 2 x squared. Now rearrange, now setting this one to 0 because one property of the derivative, we can solve this equation. So now we have 15 equals 3 over 2x squared. Dividing by 3 over 2, so dividing by 3 will give us 5 times 2 will give us 10 equals x squared, and therefore x must equal root 10. Why is it only plus? Well, because first we need it as a length. The length can't be negative root 10. That's for sure as hell. So it's going to be root 10. So using this one, using x equals root 10, I'm just going to save it at the top because it's going to be useful later. So x equals root 10. Now differentiating this one again, so the second derivative is to show that this is a max or min. Differentiating 15 is 0. Differentiating this one will get negative, dropping the power, we're going to get 3x. 3x, yeah. Why? Because, well, 2 cancels out the 2. It'll be 3 times 2 over 2. 2 goes, we left it 3. Draw the power by 1, you get this. And of course, using our x equals root 10, we can clearly see that this is a negative, and hence this is a maximum. Okay, not bad, not bad. So we kind of proven it's a maximum. Now what do we do here? Well, now we just pop in root 10 into this equation to find the actual maximum volume, because that's our purpose. So our purpose is to differentiate twice to prove that the value used is lower than 0, the derivative is lower than 0, and then hence that implies the maximum. So we can call this one V max, which is 15 bracket root 10 minus root 10 cube over 2. And what does this give us? Well, in the calculator you should get 10 root 10 centimeter cube, or if you like to work in decimals, you should get 31.6 centimeter cube to 3 significant figures. And that's it, guys. Hope this video helped, and if you got any other questions or any other shapes or 3D shapes or even 2D shapes, just let me give me a message, drop me something, and I shall get back to you. Ciao, guys. See you soon.